Hi, I'm Noah, and today we're going to be doing something a little bit different. Arduino basics! And today we're starting with breadboards. Now you might ask why a series called Arduino Basics is starting with something that, well, isn't an Arduino, but this is what I decided to do. And really, you need to know breadboard circuitry in order to use an Arduino or do anything interesting. So feel free to complain if this offends you. These are solderless breadboards. They allow one to design, test, and build circuitry quickly and with zero cost outlay. They function using rows of metal conductors which allow components to be plugged in and connected in very specific ways. These connectors run perpendicular to the spine of the breadboard, with the exception of the power buses on either side, which run parallel. They come in all shapes and sizes. For example, this mini breadboard has no power bus, but is incredibly useful for small projects. The basic concept is just plug stuff into the breadboard in such a way that it connects where you need it to connect, and it doesn't connect when you don't want it to connect. Radical concept, I know. So let's make some circuits. For this, we're going to need some LEDs, resistors, jumper wires, and buttons, and maybe a potentiometer. I've chosen 220 ohm resistors, although the resistor you use is sort of flexible. I wouldn't go much smaller than 220, as the LEDs might risk burning out, but I also wouldn't go over 1,000, as it would decrease brightness. So I have an Arduino here for power. Don't get too excited, we're just going to use it as a 5-volt power supply for now, not doing anything fancy. My first step is to connect the Arduino power pins to the breadboard power bus. These are the 5-volt pins for 5-volt power and the GND pin for ground, or negative connection. I'm going to be using ground, negative, and cathode interchangeably, as well as 5-volt and positive. So if that offends you, please feel free to not let me know about it. Thanks. I've hooked my Arduino up to the breadboard, and now that we have power, I'm going to be doing all my wiring while the Arduino is still plugged in, as I like the thrill of it, almost like as if it's an extreme sport. Seriously though, it's such a small amount of voltage and current we're dealing with here, it can't hurt me. So we're going to start by wiring up a simple LED. I have some 220 ohm resistors here. They come in both blue and brown, although they are identical in function. If you don't know what size yours are, just reference a resistor color chart, like this one. Here's my LED. You will notice that it is red, and that the legs are different lengths. The longer leg is the anode, or positive terminal, and the shorter leg hasn't quite grown in yet. Just kidding, it's the negative terminal, or cathode. I had you there for a minute there, didn't I? So I'm going to plug my LED into the breadboard, making sure that the legs are in 2 different rows. Then I connect the negative terminal to the negative power bus using a resistor. This is done because the LED cannot handle the 5 volts directly from the Arduino, and will burn out if there's no resistor there to drain some of the power. The resistor can be attached to either the negative or positive terminal. It doesn't really matter. Now, all that's left is to connect the positive terminal to the positive power bus using a jumper wire, and it turns on. You'll notice that if I flip the LED around, reversing the anode and cathode, that it does indeed not work. This is because LEDs are directional. In fact, their name stands for light emitting diode, and a diode, of course, is just like a one-way valve for electricity. Let's take a quick look at how this works. The electricity starts at the positive terminal on the Arduino, where it travels down this red wire into the breadboard power bus. It is then picked up from the bus by this other red wire, which brings it to this row on the breadboard. It enters the anode of the LED, which emits a light before it exits at the cathode. It travels through the resistor and into the negative power bus, where it is picked up by the blue wire and sent back to the Arduino via the ground pin, thus completing the circuit. That was really simple, and really not that useful. To add a small degree of control to the circuit, we can add a button, like so. Now we essentially have 2 circuits. The red LED is always on, and the green LED is usually off, except when we connect it to power by pressing the button. This is all made possible by some quick and easy breadboard connections. Now for something that's actually kind of useful. Here we have an LED hooked up to a switch and a potentiometer. The switch is obviously just a more permanent button, and the potentiometer is a simple variable resistor. It works exactly the same as our resistor from earlier, except when you turn the knob, it changes the resistance, thus changing the brightness of the LED. Basically, I've made a dimmer switch. So let's quickly go over how it works. Power comes in through this red wire, where it enters the power bus. It is picked up by this other red wire and delivered to the LED. Assuming the electricity is still flowing, it will light up. The electricity leaves the LED via the green wire, where it is slowed down by the potentiometer. This will sort of back up the flow of power, reducing how much of it reaches the LED, Think of it like traffic. If you merge a 5-lane highway into 2 lanes, the cars behind slow down, and everyone misses work. Anyways, the electricity exits the potentiometer using the blue wire and enters the switch. The switch is kind of like a bridge with roadworks on it. No one can cross, and thus the flow of traffic halts completely, provided there are no other bridges. You know what, this is an analogy, just work with me here. Assuming the switch is closed, there are no roadworks on the bridge, and the electricity can pass through. If the switch is open, the circuit is complete, and the flow of electricity to the LED halts. Thus, it is no longer illuminated. So, let's see if this actually works. Switch it on, turn the dial, and there we go. You can see how I can vary the brightness by turning the dial, and how I can emulate an ambulance by flashing the light. When I flip the switch, no matter the potentiometer position, the LED will switch off. So there you have it, how to use a breadboard. This was incredibly basic, but the same concept can be scaled up and used to make more and more complex circuits. Anyways, if you enjoyed this video, maybe stay tuned for the next video of Arduino Basics, and subscribe if you feel like it. Otherwise, have a great day, and thanks so much for watching.